Hi, my name is Naya, and I'm joined by Edgar, Zachary, Matthew, and Rebecca. In this experiment, the law of physics being studied is Newton's second law of motion. Within this experiment, we will be analyzing the relationship between the mass and acceleration of an object. As the acceleration of an object increases due to its mass, the force of the object will increase as well. Because the acceleration of the object is inversely proportional to its mass, we should see different forces applied to each figure. The materials used to conduct this experiment included a 1.2-meter ramp at a 5-degree incline, a box cart, two 50-gram weights converted to 0.05 kilograms, and a video analysis app to help construct our data. With these tools, we organized 3 separate trials, each with a different mass to calculate the differences in both acceleration and force. Our first trial being the initial mass with no extra weight added to it. Our second trial had 1.05 kilogram of weight added to it, and our third trial had 2.05 kilogram of weights added to it. Our first graph shows cart 1 having the initial mass of 0.24899 kilograms. The slope of the velocity versus time graph equals the acceleration, which gives us 0.3941 meters per second squared. Our second graph shows cart 2 having one of the 0.05 kilogram weights added to it, giving us a total cart mass of 0.29899 kilograms with a slope and acceleration of 0.3808 meters per second squared. Our third graph shows cart 3 having both of the 0.05 kilogram weights added to it, giving us a total cart mass of 0.34899 kilograms, with a slope and acceleration of 0.3653 meters per second squared.
With the data gathered from the experiment, we can now analyze the relationships between the force, mass, and acceleration of an object. As displayed, the object with the largest mass had the smallest acceleration. Considering the data obtained, the mass and normal force of the object are directly proportional. The mass and acceleration are inversely proportional, which supports Newton's second law of motion. Previously stated, the net force is directly proportional to the acceleration of an object. However, in this experiment, the normal force was calculated and is shown on screen. The normal force is not always the net force. In conclusion, increasing the mass resulted in a constant decrease of the object's acceleration and a near constant increase in the normal force.